Hey everybody, wanted to go through a couple of problems that we didn't have answers for solutions for on the reference sheet. Thought that talking through some more of the difficult ones might be helpful. So a couple of things first. As you can see up over here, oops, too far. Up over here I've got the Pythagorean Identities up there, so then that way we've got the reference, because everything we're going to do is going to be based off of these. And I'll have the problem that we're working on down below. And I think that should take care of it. We're in my new handy dandy classroom studio. Got a big dry erase board now, so we should have no excuses about not being able to read this. So, before I forget, I always forget this part. Make sure you hit the subscribe and the little bell so you guys can always make sure you get all your Pythagorean identity videos as soon as you can. So anyway, so again, first problem that we're doing, make sure I get this. Secant x plus tangent x is equal to cosine x over 1 minus sine x. Now, we talked about when I was walking through some of those with you a few weeks ago, that one of the plans here is to make sure that we use these as much as possible. One of the other techniques that we had talked about is that when we've got two terms that are turning into a single term, the question is, how can I combine these together? A couple of reminders. Remember, we're trying to prove that these two things are equal, so I can't mess around with both sides. So my first step, so actually, let me write this up here so we don't get confused. And again, I do have it right down here. So anyway, sorry. So anyway, we've got, so I'm going to start here with secant x plus tangent of x, and I want to get it down here so that towards my last step is going to be cosine x over 1 minus sine x. Okay, so, and again, the reason why we do this is because that way, if we want to look at this and maybe take a step or two backwards, then that way we can kind of say, oh, that's what we're shooting for. But before I even worry about that, pardon me, is that the first thing that strikes me about these two trig functions is the fact that you can write them both as quotients. You can rewrite them in terms of sine and cosine. And watch how nicely this falls apart. So this is going to equal, so secant x plus tangent of x is the same thing as 1 over cosine x plus sine x over cosine x. Those things should be things that you know in the back of your head, okay? From there, you're like, huh, I don't even have to find a common denominator. That's beautiful. Because then this is going to equal 1 plus sine x, and that's just going to become cosine x. Common denominator, single fraction. And great. Now, you're saying, Mr. Hayes, wait a second. I need to get 1 minus sine x. Okay. The other thing that should be going off in the back of your head is this. Remember, everything up over here that we have up here in our Pythagorean identities, okay, is squared. The other thing that you need to have in the back of your head, next, okay, is that, remember, if I have a squared minus b squared, that's going to equal a plus b, a minus b. Okay? So for example, if I look up over here at if I were to change, for example, one of these so that I would have minuses in them, so maybe this one I would transfer into 1 minus cosecant squared is equal to the opposite, cotangent squared. You could start messing around with this. But more importantly, I can do the same thing up over here. I'm getting used to that, sorry. Up over here, I can mess around and say, wait a second, I can move sine squared to the other side. Why am I going to move sine squared to the other side? Because look, I've got 1 plus sine x here. So if I can make it 1 minus cosine squared, or 1 minus sine squared x, I've got some flexibility. First of all, I need to get squared terms. The question is, how are you going to do that? You've got a couple of different options. One option, because again, I'm looking for a cosine here, would be to multiply the top and the bottom through by, actually let's go ahead and do that. It's a little bit easier. I was going to do it a totally different way, which I think actually may be a little bit more confused. So we're going to do this. I'm going to multiply this by 1 minus sine x. 1 minus sine x. Why am I multiplying through by that? A couple of reasons. First of all, these are the factors of difference of perfect squares. That's going to allow me to use this property from up here. The other thing that that's going to do is notice I want 1 minus sine x as my denominator. And so because of that, I now have it. Ka-ching. So let's multiply this out. Do I always want to multiply it out? I wish I could say yes. Kind of depends on where you want to go. Now remember, from up here, okay, I could go through and I'm basically saying I'm subtracting sine x on both sides. So I'm going to have cosine squared x is equal to 1 minus, actually for up here, let's say, I'll keep it with what I have over there. I'll have that. Okay? So this is going to be the version of the Pythagorean identity, sine squared plus cosine squared is equal to 1, that we're going to end up using. And you don't have to show anything specific of that. That's going to be adequate. So once I multiply all this stuff through, watch what happens. I get 1 minus sine squared x. Why? Because I've got the two factors of a difference of perfect squares. I really hope at this point of your math careers, you notice that, because I've got 1 plus, 1 minus, that you don't have to multiply that out. I really do not want to see you foiling this out, multiplying it out, whatever. Box method, don't. Okay? At least not at this level of math. And then down over here, I'm going to have cosine x 1 minus sine x. I can hear some of you saying, but Mr. Hayes, you didn't multiply this out. You're right, I didn't. Why wouldn't I? What do I want? Okay? If I multiplied this out, I wouldn't have where I'm going. So that's why, and this holds true, not just math, you always begin with the end in mind. Okay? So once you do this, you know that through the Pythagorean identity, what's 1 minus sine squared going to turn into? 1 minus sine squared of whatever is equal to cosine of whatever. So this is now going to turn into this. And I hope now you can see exactly where we need to go, because what's the next step? Well, look, cosines are going to divide out. So then in that case, that's going to go right there. And then remember what we do at the end, check mark, QED, quod erat demonstratum. You can also say quite easily done. Okay, pause and rewind as you need to. We'll see you in a second. So, second problem we're going to do is number 14. And as you can see, it's right down over here. Still have our Pythagorean identities up here. And again, much like we've always talked about, this up here, the difference of perfect squares, factoring is always going to be a help. So that's why you need to know these things. All right, so we're starting up here. Now again, like so much of this, just sitting and watching me do this isn't going to be as helpful. You need to be physically writing some of this stuff down. Or, watch me first, then go back and write some of it down. Because there's some muscle memory that goes into it, but also the brain research says the physical act of writing it out actually helps encode it into your head. Okay? Think about this. Math is always the one thing that you always hear people say, oh, can't handle math. If that was the case, think about how much math those people watched. If that made people get better, if just watching math could actually make you learn math, think about how many people would actually be saying that. 0. Anyway, so again, what we're going to do here, now the question is, now I've got 2 terms over here, 2 terms over here. So you're like, okay, I probably don't need to worry about any common denominators. And the answer is correct, you don't. So then at that point you start saying which one looks more complicated. It's always easier to make things, while it's easy to make things more complicated from a simple standpoint, what is not easy to do is make it complicated in the right way. So oftentimes it's much easier to take a complicated problem and make it simpler. So because of that, I would suggest starting here with sine to the fourth x minus cosine to the fourth x. Now again, bell in your head. Think back to what we did with factoring. First of all, this is a difference of perfect squares. Sine squared squared is sine to the fourth. Cosine squared squared is cosine to the fourth. So you're thinking difference of perfect squares. So already, before I do anything, this should be popping up in your head. And you should be thinking, man, if I break this down, that does two things. Notice I get into where I want to get cosine squared there. So that's the other thing to be, that should be one of the things playing around in your head. Okay, so that would be the first place that I'm going to start. So again, what I'm going to do, and at this point, I know toilet paper might be a little bit harder to find. Hopefully written paper, regular 8.5 by 11 paper, not so hard. Don't try to save space on this. Seriously, okay? So, but Mr. Hayes, I will buy you more, okay? I've done this long enough that the best thing to do is have space and not try to cram it down. So, sine to the fourth x minus cosine to the fourth x. That's where I'm starting. Again, where am I going? I want to end up here. So I want to start, and I'm going to end. The one thing I need to do is write bigger generally, but we'll see how this goes. So anyway, the first step, as I said, I see a difference of perfect squares. Now, why would I go ahead and, but Mr. Hayes, that's not easier. But remember, we've got our Pythagorean identities up over here. What is sine squared plus cosine squared going to equal? It equals 1. What is this going to factor out to be? Square root of the first term plus the square root of the second term, square root of the first term minus the square root of the second term. Wait a second. I think our lives just got a little bit easier by making it a little bit more complicated. So this is going to break down into there's my first term, first expression, first factor. That's what I'll say. Times. Now look over here already. Ding, 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 ding. Remember what I said. If you have two trig functions that are squared, or a 1 and a squared function, you should automatically start thinking about these. Okay? So anyway, I get this. I get the minus part of the factor. And now again, this is equal to 1. So all of this is just going to turn into a 1. 1 times anything is just the anything. So all of this is just going to simply, this is just going to come down here. And I'm going to get sine squared x minus cosine squared x. Okay. Let's take a second to look at where we're at. I want cosine squared x. I want 2 of them, but I need cosine squared x. I have 1.
Hello there.
Why, thank you. So I want cosine squared x. So I've got 1 of them. I want 2. I have 1. So now the question, so I'm not going to mess with this. In fact, I want minus 2 cosine squared x. So I already have the minus. I am already about a third of the way there. So the question is, how can I mess around with sine squared x? Again, remember what I just said. I have sine squared. I want a 1. So back up here again, I should be messing around with this. So the thing in the back of your head which you need to ask yourself is this. Based upon what's coming out of here, okay, what is sine squared theta really worth to you? Go this way. Okay. Sine squared theta, what do I need to do? I need to take cosine, to get sine squared by itself, I have to subtract cosine squared from both sides. So that's going to equal 1 minus cosine squared theta. So now at this point, but through the Pythagorean identity, this, sorry, I have a table. Yeah, I'll go this way. I have a table there, so I can put stuff. Anyway, so what ends up happening here is that this, okay, I'm going to write this down this way. Sine squared is equal to 1 minus cosine squared. So this is, so that way I remember what I did. So this sine squared x is turning into 1 minus cosine squared x. I know. You see it, don't you? Right. So then that is going to turn into so I've got 1 minus how many cosine squared x? I have 1 cosine squared x here, a second one here, so I've got 2 cosine squared x's. Hey, that's where we want to go. Okay? We're done. It has been demonstrated. Cool part about math is that if you remembered this, once you show this, you never have to do it again. Well, unless I ask you for a quiz or test. But in terms of stuff, well, it doesn't matter. You'll learn about it in grad school. Or actually, probably even just undergrad. It doesn't matter. So, hopefully that's helpful. Hit subscribe, hit the little bell, shoot any questions off. Ask your teacher, ask me, whatever you need. Hopefully this helps give you some of the background in terms of what's going on. And we'll see you soon. Thanks.